You ever stop and wonder how your favorite app just knows you? Like it knows what you like, or how your bank keeps perfect track of every single penny? Well, it's not magic. Not at all. There's this invisible architect, working behind the scenes of our entire digital world. And today we are pulling back the curtain on that architect, the database.
I mean, seriously, think about it for a sec. Your login details, that thing you left in your shopping cart, your progress in a video game, your watch history, how does it all just stay there, waiting for you when you come back?
Well, the answer is actually pretty simple, but it is incredibly powerful. It all comes down to one core piece of technology, this master system of organization called the database. This thing is basically the digital memory of the internet, and today we're going to figure out how it works.
So let's start with the big question. What exactly is a database? Now, it's really easy to just think of it as some kind of giant complicated spreadsheet. But honestly, that's like comparing a bicycle to a freight train. Yeah, they both have wheels, but they are built for completely different jobs.
At its very heart, a database is just an organized collection of structured information. Now, the key words there, the ones you got to remember, are organized and structured. This isn't just some random junk drawer of data. It's more like a perfectly arranged library, where every single piece of information has its own specific spot and a clear connection to everything else around it.
And this is where that whole spreadsheet comparison just falls apart. Look, a spreadsheet is great if you're one person managing a simple list. But what happens when you've got thousands or even millions of people all trying to get in and change information at the exact same time? A spreadsheet would just collapse. A database, though? It's designed for that chaos. It can handle massive scale, super complex connections, it makes sure all the data is accurate, and it lets tons of people use it at once without anything breaking.
Okay, so before you can build any strong, reliable building, you need a plan, right? An architect doesn't just show up and start throwing bricks around. They draw a detailed blueprint first. And in the world of databases, that blueprint has a name, the Entity Relationship Model.
Just think of this model as the designer's map. It's how they look at a really complex system, like a university or a hospital or an online store, and break it all down into its most basic pieces and then figure out how all those pieces connect to each other.
All right, so the first piece of our blueprint is the entity. The easiest way to think of an entity is as a noun. It's just a thing, a person, a place, an object that we want to keep track of. So in our university system, the obvious entities would be student, course, and professor. Each one is like a bucket we're going to use to hold a specific type of information.
But, an entity by itself is just an idea. We need to add some details. So if the entity is the noun, then an attribute is the adjective. It's a specific piece of information about that entity. For our student entity, attributes would be things like their name, their student ID, their major. For a course, it'd be the course ID and the title. You get the idea.
And finally, we have the relationship. This is the verb that connects our nouns. See, entities don't just exist in a vacuum. A professor teaches a course. A student enrolls in a course. These relationships, they're the glue that holds the entire blueprint together. It's what defines the logic of the whole system.
Okay, so we've got our blueprint. We know our entities, our attributes, and our relationships. Now it's time to put down the pencil and start building. And for that, we need a special set of tools and a very specific language to give instructions. That language is called SQL.
SQL is, and this is no exaggeration, the universal language of databases. It doesn't matter if you're working with a giant corporate system or just a tiny personal project, SQL is how you talk to the database. It's how you tell it to build things, add data, and ask it questions.
Now you can think of SQL commands as having three main jobs. First, you've got the construction crew. That's DDL, or Data Definition Language. They build the actual structure from our blueprint. Next up, you've got the librarians. That's DML, or Data Manipulation Language. They put data in, take it out, and change it. And finally, you have security. That's DCL, or Data Control Language. They control who gets to see what.
Let's see this in action, right? A command like create table students, that's pure DDL. That's our digital construction crew getting to work. This is us literally telling the system, okay, based on that blueprint, I need a container. Call it students, and it needs columns for name, student ID, and major. We are laying the digital foundation right here.
So, our structure is built, but it's empty, and an empty library isn't very useful, is it? So now we need to call in the librarians, those DML commands, to actually fill our database with information and start interacting with it. It's time to bring this digital building to life.
Let's tell a little story.
A new student, let's call her Jane Doe, enrolls. To get her into our system, we use the insert command. We're just telling the database to pop her record into that students table we just made. And boom, just like that, her data's in. But now that she's in there, how do we find her again?
Well, for that, we use the select command. And this is probably the single most common command in all of SQL. It's how we ask questions. Saying select star from students where name equals Jane Doe is basically us saying, hey, database, go into the library, find the file for Jane Doe, and bring me everything you've got on her. Simple, but what if Jane decides to change her major?
Right. Data isn't static. It changes all the time. So for that, we use the update command. This lets us go find Jane's record and just change the value in her major column from, say, physics to computer science. And then, years later, when Jane finally graduates,
Well, that's the final step in her data's life. The delete command permanently removes her record from the active table. And just like that, our little story of creating, reading, updating, and deleting data is complete, all thanks to our DML librarians. Okay, so we've designed a blueprint. We've built a simple structure. But why does any of this really matter? Because these exact same principles are running silently behind almost every single digital thing you do every single day. That feed on your social media app, that's a database query. Your bank balance, stored nice and safe in a database. That item you left in your online shopping cart 3 days ago? Yep, held there by a database. Your Netflix history, your character's inventory in a video game, I'm telling you, it is all databases all the way down.
So the crucial point is this. Every click, every purchase, every single piece of data that you touch online lives inside a structure that was defined by entities, attributes, and relationships, just like the one we designed. It's all managed and pulled up using a language just like SQL. This invisible architecture, it's literally everywhere.
And now that you understand the basic blueprint, you've kind of gained a new superpower. Seriously, the next time you're using an app or a website, just take a second. Try to see past the screen. Ask yourself, what are the entities here? What are the relationships? Because now you can see the invisible architect at work. The blueprint, well, it's not invisible to you anymore.